Hello everyone, welcome back to the channel Master the Codes, and today we are gonna talk about graphs. I'm starting a complete series on graphs so that everyone who wants to understand data structures can get to know this particular data structure graphs much better because it is quite commonly asked in interview questions, especially in FANG companies and in higher two tier or one tier MNC companies as well. So all those who are striving forward to getting a good placements, cracking interviews, this particular series is just for you. So without wasting any more time, let us get started. Okay, now this will be a beginner to advanced series. So the first few concepts might be familiar to someone and some concepts might be new to someone else. So let's get started. Today we are talking about graphs. They are a non-linear data structure. Now what do I mean by a non-linear data structure? In a normal data structure like an array, which you might have heard about or worked upon, the data is stored in a sequential manner, and that sequence is maintained by the index, right? That is termed as a linear data structure, and there are of two types. One is a linear data structure and other is a non-linear data structure. In linear data structure, the other types of data structures are queue, stack, linked list, and arrays. In non-linear, the main difference is, or the primordial difference is, the data is not stored on the basis of indices. Like it is, even though it is stored in the basis of indices, but it is not in a linear fashion. Like if you see a matrix, each row and column is designated an index. The rows are designated by I and columns are designated by J, but they are not in a linear fashion. So that is termed as a non-linear data structure. Examples are graphs, which we are going to talk about, trees, matrix, and heaps. Now there is a difference between a tree and a graph. A tree always contains a root node and its edges are directed. Like from parent, you always reach the child. It follows a parent-child relationship. That is termed as a tree. But in graph, this is not the case. From a start node, you can reach to any other node such that it allows, the direction allows it. There is no specific start node or end node. You can choose the start and end as here. You can choose the start and ends like here, or you can choose start and end the same node itself. That is a graph. Now, they contain nodes and edges. Now, what are these nodes and edges? Nodes, they store data. Since we are talking about data structures temporary, like primarily work on the backend and they store data. Now in, if you're representing a graph or if you're using a graph, it must store data somewhere. Now where it stores data, those points are termed as nodes, or you can say they possess a unique ID or a unique index. So you can say at the specified indices where the data is stored, such indices are called as nodes, and edges are the connections between those nodes. They connect the two nodes, right? Nodes, they store data, and edges, they connect the two nodes. Like if I draw a graph over here like this, these are all edges which are connecting the nodes, whereas this n1 and n2 are the nodes that are being connected by the edge e1. So if you want to represent it, it can be represented as a tuple like n1, e1 and n2. Coming to the types of graphs, there are multiple variations in graphs. The first one is unidirectional. Now what do I mean by unidirectional? If I have a graph like this, a graph contains directions, the edges are directed over here such that you can traverse from 1 to 4, but due to the edge you cannot traverse from 4 to 1. It is not possible. So that is a unidirectional graph. Also, unidirectional graph may contain cycles. In bidirectional, the path goes either ways. From node 1 you can go to node 2, and from node 2 you can go to node 1, and it may or may not contain edges as well, or sorry, cycles. Now what is an acyclic graph? A graph which does not contain cycle. It may or may not be directed, but it never contains a cycle. That is an acyclic graph. It do not contains a cycle. That is, if you start from node 1 and you follow a specific path or a distant path, you will never reach node 1 again. Of course, you can backtrack, but you will never reach node through a path. Now, what do I mean by directed? Directed graphs are sometimes referred to as weighted graphs as well, where the graph contains weights. That is termed as a directed or weighted graph. Coming to a cyclic graph always contains at least one cycle. Now, a minimum spanning tree. A minimum spanning tree, I will be explaining you before this, but let me give you an example first. Now suppose you have this graph and I am asking you what is the minimum number of edges you need to keep the graph connected. Now what do I mean by connected? From node 1 you should be able to travel to node 4. That is, from node I you should be able to travel to node j, where I and j, both the nodes belong to the graph G. Now, how to do that? For that, if you look closely, you can remove this particular edge and then you will be able to reach all the nodes from any node, right? Or you can even remove this edge as well, that is up to you. So the graph will look like this. And it becomes a minimum spanning tree. If you say mathematically, for n number of nodes, a MST has n minus 1 edges. That is termed as a minimum spanning tree. Now what is a complete graph? A graph where each edge, or sorry, each node is connected by every other node. That is termed as a complete graph. So if you say node 1 is connected to 3 nodes, that is 2, 3 and 4, and similarly 4 is connected to 1, 2 and 3 and so on. That is, I is connected to n minus 1 nodes, right? So for each node n, there are n minus 1 edges, or rather I should say, for each node I, there are n minus 1 edges, right? So that is a difference between a complete and a minimum spanning tree. We can change a complete graph into an MST, but we cannot do vice versa. That is, by in complete graph we can remove certain edges to make it look like this, but we cannot add multiple edges to make it in complete graph unless and until in the question it is given itself. Now there are some operations on graphs that everyone should be aware about. The first one is create. Now a thing arises, okay, we know the understanding about how a graph looks, we can even draw it on a pen and paper, but how do I create it in terms of a programming language? No worry, that's why Master the Codes, the channel, is here for you. So please like, share and subscribe to the channel and hit the icon or bell icon for more notifications. Now let's take this particular graph, 3, 4. In terms of data structures, we can create a graph using a map and a list. Now, what do I mean by this? A map contains keys and values, right? I would represent keys as the node number. So I would name them as 1, 2, 3 and 4. These are my keys. Now in terms of values, it would be a list. Right, it would be a list where each list would represent the neighbor of the current node. As you can see, 1 is a neighbor of 2, or rather 2 is a neighbor of 1, and similarly 2 is a neighbor of 1, 3 and 4. Similarly 3 is a neighbor of 2 and 4, and 4 is a neighbor of 2 and 3. So if you represent the node number as the key and the neighbors as the value or the list, you will be able to get the details of the graph, or will be able to construct or create the graph. This construction is termed as an adjacency list. There is another way as well, that is adjacency matrix, which we're going to talk about in the next videos, but this is the most easiest and the important way of creating a graph. Now, whenever we are creating a graph, we need to traverse all the nodes at least once, so that would take order of n time. In searching, we simply need to find whether node 2 is present or not, right? So for that we can just hit the check function of a map. If map dot contains the node 2, then print yes, otherwise false. And searching a map takes order of 1 time. Similarly, if you want to add, let's say I want to add a node 5. So how can I do it? I would simply create a key value pair again and add the required information such that this particular keys would be incremented by another value, let's say 5, which is the neighbor of 2. And similarly you need to increment over here as well, which is 5. And the graph will look like something like this. There is a node and a 5 gets attached to it. And since we are just updating one key and one value, that would take constant amount of time, and hence order of 1 for add operation. Similarly, the way you are adding, you can delete that. Just find the particular node number which you want to delete. Let's say I want to delete node number 1. Just search the node number 1, extract it and remove it from the map. And removal also takes order of 1 time. I would be given the codes as well in Java. The main thing is you need to know the knack of it, like how to use map and list, and the only difference is the syntax in the programming language, otherwise everything is same. Now there are a few algorithms for traversal as well. Now suppose you have created this graph and you want to traverse it, right? Or let's create another graph and you want to traverse it. How to do it? I will be creating a graph over here. Let's say this is the graph. Right. In BFS, the data structure which we use for traversal is queue, and it works on the condition of FIFO, that is first in, first out. Now what we will do, we will initialize a queue and add the source, like from the node where we want to start, and we would give it 1. Right. So I will create the queue, add the source and assign it 1. And at the same time, before this initialization, I will create the adjacency list of it. So 1 is connected to 2, 2 is connected to 1 and 3, 3 is connected to 4, 2 and 5, 4 is connected to 3, and 5 is connected to 3 as well. Now when we have reached this queue, I will add all the neighbors of the queue in the list and remove it. The only neighbor which the queue has is 2, right? And since there is 2 over here, and I'll mark 1 as visited, like I have visited 1. Now I have moved to node 2. Similarly, I'll add the neighbors of 2 into the queue, but first I'll delete it. And the neighbors are 1 and 3, but 1 is already visited, as you can see over here. 1 is already visited, so I will only add 3. Now I will remove 3, and while removing I will add the neighbors of 3. And since we had visited 2 in the previous step, we will mark 2 as well. Now the neighbors of 3 are 4, 2 and 5, and since 2 is already visited, I will only add 4 and 5. Now I'll remove 4 and check the neighbors of 4, which are 3, which is visited previously, and so I will not add anything, and the queue will now contain only 5. Now I'll remove this 5 as well and see all the now the 5 is connected to 3, and 3 is already, you can say, visited, so I will add nothing and the queue becomes empty. And when queue is empty, the BFS ends. So this is how BFS works. Now there are few things which you need to maintain while doing BFS. First is a queue of data type node. Like, node means the type of data you are storing, whether you are storing an integer, whether you are storing a string, or something like that. An adjacency list and a visited array to mark the nodes that are visited. And for that you can either use a bit mask or you can use an array itself. All of this I'll give explanation in the code, like how to do all of this, but for now you can just keep that in mind. Now coming to DFS. Right, now I have reached the DFS and I am implementing the same thing, but in DFS it would be done by stack, that is LIFO, last in first out. Right, now let's create the stack. First I'll have the stack, I'll push 1 into it. Right, then I'll push all the elements of all the neighbors of 1 in the stack, but I will not remove it, since the removal takes when all the neighbors are traversed. In queue the removal take at the same time, like you can see over here, but in stack the removal is done when all the neighbors are traversed. Right, so since the neighbors are not traversed, I will only add 2 over here. Then I'll go to the stack, I'll see 2, and then the neighbors of 2 are 3. I'll mark 1 and 2 both as visited because they have been visited once in the array. Now I have reached 3. I will mark 3 visited as well. Push the elements, all the neighbors of 3 in the stack which are not visited, that are 4 and 5, and mark 4 and 5 as well. Now the 5 contains neighbor, that is 3, and 3 is already visited, so it means all the neighbors are visited. And now I will remove 5 and I am left with 1, 2, 3 and 4. Then you can see 4 also contains the element 3 which is visited, the only neighbor. I'll remove 4, I'll give 1, 2 and 3. Now you can see 3 contains neighbor 4, 2 and 5. All the 3 neighbors which are completely visited, 4, 2 and 5. I'll remove 3 and I am left with 1 and 2. 2 contains neighbor 1 and 3 which are visited. I'll remove 2. And at last 1 contains the neighbor 2 which is visited, and the stack becomes empty. And when the stack becomes empty, the DFS ends. Now there are things that you would need for implementation. First is an adjacency list, then a stack, and a visited array, which can again be a bit mask or it can be an array itself. I will explain all of this in the code in the next video, but for that, please like, share, and subscribe to the channel. If you find the explanation good, I'll give the codes in the link in the description down below. So please share to have a look at them, understand them. I will explain about them in detail in the next video. But for then, please like, share, and subscribe, and let's meet in the next video. So until then, bye bye. Have a good day.